As I said in the last video, I wanted to show you something more, a different framework. It's the Spock framework for unit testing and doing some mocking. It's a framework written for the Groovy language. You could use this in every project that you use the JDK in, for example. In order to do that, we just need to include and change a little bit in our build Gradle file. First thing, we apply another plugin here, the Groovy plugin, to enable the Groovy language features that we actually need. We need to write some Groovy test code in order to the IntelliJ IDE to know that there are Groovy classes in special folders, like the Groovy folder here under test and the Groovy folder under main. We have to apply the plugin. We also need to add the Groovy all dependency to the compile thing here, and some other frameworks, the cglib thing to mock classes, not only interfaces, and the Spock framework we use here, release candidate, very new version of the Spock library here. And if you do that, we are good to go. We can just create a unit test specification. Actually, it's named in Spock. In order to do that, we can use Control-Shift-T, create a new test. We actually name the test not test, we name it spec because we have already a test. You could also name it test if you like. So we now want to create it in the demo package. As we have two, we have to choose. We want, as we write Groovy code, we have to choose the Groovy destination here, otherwise it wouldn't get compiled all the way. Yes, we want to add it to our repository. Okay. Now we have a specification. Specification is something like the basic class of every Spock test. As I want to show you what actually Spock looks like, I just will copy the things from the Mockito test example from before, and I will just cancel here because I'm not interested in getting all the things in it here. I just wanted to show you or give you the hint how it actually looked like before when you used Mockito. Maybe it's get a little bit easier for you. We don't need mock here. What we do in Spock is instead we actually call the mock method. And therefore we provide a class. In Groovy you can skip the .class thing here. You don't have to, you can put it there, you don't need to. You can just skip it. Same goes for the semicolon here at the end. We don't need that either. The next thing, we don't use inject mocks here. We use instead the subject annotation. It's just a marker annotation from the Spock framework, which actually tells Spock which is the actual object that we run tests on, or run test against, or write test for. This one is just, we call here just a constructor. It's a new animal service and pass the mocked object and a repository to it. So now we have just configured everything. Now we want to rewrite this test here. I just commented out, so you might have a look at it to compare. The cool thing is in Groovy, you might use anything you like as method names. Def is something like, I don't care what it returns, we just define a method here. And the method could have some really cool name. We want to test, for example, the get animal by name method. And And then we could say, oh, I want some spaces in it, and say, oh, this is test case number 1. And the animal that we are looking for doesn't exist. So you can write complete sentences, don't have to use any underscore syntax here, whatever. This is just a simple method name here. It's for test cases really cool because you can describe what your test actually does. So now we have defined our name for the test method. Now we have similar things than we have in Mockito. Now have to do some stubbing. We want to define the behavior of the get all elements method, so that returns a list of 2 cats, Mike and Peter. In Spock we define, we have 2 blocks. We have a when block and the then block. This is the first thing I want to show you. In the when block we put the things we actually want to, like the stubbing, the call of the method we want to test, and in the when block we verify things. So what we actually want to do in the when block is we want to do mocking, and we do that by typing how many times we want the method to be called. We want the animal repository dot get all animals method to be called once, and now we use the shift operator as an overridden operator in the Spock language here, which is a groovy sub-language, and it just means that the one invocation of the animal repository get animals call just returns a list of new cat Mike and new cat Peter. These parents here are defining list literal, so it's something like new array list, and then you add a cat Mike and a cat Peter to the list. This semantically and syntactically the same thing. Now we have just written the same thing as here. This is quite the same, nothing different. The next thing we do is we actually call the method, and as above we could use found, for example. We don't need to declare the type here because Groovy is not so strictly typed like Java, and we can just use def, and the Groovy type inference does the work for you. So we can just call our method that we want to test, say animal service get animal by name, and we want to call it with mark like in the example above. So, and that is what we do in the when block. We define our stubbing, we make our method call, and in the when block we actually verify. And for the verification, we don't need to insert that. We could put that in this particular thing here. We can use that, but we don't need to actually. We can just provide something like found what is present, and say we don't want found to be present. And the cool thing is, if you define that on this level here, no sub scoping, no sub logging, so you don't have to use another parent up front, another block, define another block. You can just use true and falsy things here as statements, and then Spock automatically puts an assert before that and does something like assert these statements here. So this is the same semantically and syntactically the same thing as above, but much more readable from my point of view. So now we can just run this method and see if it works. And the test method, simple, just another unit test. You can see that here. And we wait for the thing to build here. You can also use here something like an underscore for I don't care how much times it calls. It was called. You can also use here not this literal. You can also return a new area list and put the parameters in it and whatever. If you like more Java guy, maybe it's more easier to start with. So now you can see the test actually passed, and the method test case method has a pretty cool name. So let's go on. Oh, this is not the only thing that we can do, or we can think of. Maybe we have something like we don't want actually to test just one case in our scenario here. We could use more. I just start with the simpler example here. What you can do, but we shouldn't do is you can say something like when next block is when we call, I don't know, we could put the same things here again. Provide them here. We are not allowed to define that again. And we have already defined something here. So could do this here, say 1 times this, and we return this again. Call here Mike, and say now it should be present. We can run the test again. It should be green also, but you shouldn't actually do something like when then things. This isn't not a good idea, because if the first part fails, then the second when isn't actually executed. So you shouldn't should somehow divide this into 2 test cases. So you have a second test case where single then block is in. You can also use multiple then blocks. So these here. You can say then this, and then also something like, doesn't make sense in this case, but for example, you can in this case the thens are just executed in the order is specified, or the order is fixed. So you can say found is present is first verified, then not found is present is verified, and so on. If you have you can also do this way, if it would make sense for some reason. Then the order of verification isn't fixed. It could be random. Maybe interesting when you think about, for example, when you have not the stubbing thing going, when you have some stubbing going on in this when block here, and this one here. And in the then block, you actually want to verify some other method calls. Like, for example, if you think about the method of, yes, I have a good test case here. If we think of the animal service, and we look into this method here, could be the case that we actually want to verify that the add animal method is called somehow, and let's just write this test. So we just remove this here and duplicate our test case and write a test for the other method. So now we have not the get animal method, we actually want to call the was add if not existing new dog mark method, for example. So now we rename our method here, keep it simple, don't like to use any things here, just put the name test method, whatever. this method actually doesn't return anything, so we're not interested in this one here. And now it could be interesting, and we return all these animals here, and we want to verify, for example, that the animal repository at animal method is called with Control Alt V, just extract it to local variable. So you could use this here, but a pretty cool thing is you have something like given then you can put that up here. You can keep it on the other place, but this is much clearer because you define this as a variable and can reuse it in both scenarios here. So now you design that actually the dog mark call takes place. So the add animal method with the parameter dog is called. So let's run this method here again. I see that we can just depends on what you actually want to do. If you just want to verify things, then you have to put it in the then block. If you want to just stop things, then you put it in the when block here. So you have to choose somehow. See, the test passes. Okay. This is all there's to say about the when then thing. We have some more features here I'd like to show you. We can also do something like we write the get animal by name test again, and now we do something like we just want not one call, we want maybe a data table. So we want something like we want the names Mike, Peter, whatever called, the method get called with, and then want to verify that all these calls are giving some special return where you're doing some things. So we can do that and define something like we don't care how often it is called, so we say something like animal repository. We put it on mockup here. Dot get animals, always return. Let's say we return this one here again for the simplicity. After that we define, so this would be something like our given, right? And we define, we use the keyword expect. This is always some keywords if you use given, then expect, and where. Where is the other thing? Where is where we define our data table. But now let's just skip to the expect. In the expect part we would define something like our found from before, like this here. Could copy that. But the interesting thing now is we don't want here a mark, we want maybe some name. We don't know which name yet, but we want multiple names inserted here, so we put in a variable. We don't have to define that for now, because we do that just in a second in the where block. And we also want, in expect part, we would also do some verification. So what we did before is somehow asserted the is present thing. Now we may have the assertion wouldn't always be true, so we have somehow to compare the is present value against another value, another variable we don't know yet. This is where we could use a data table. Now we have our input values. This is the name and our expectation values, and we could define a data table like this in Spock. Just put the name of the variable you like to to use. In here, use a pipe or 2 pipes. It actually isn't relevant, but I would always somehow divide or provide 2 pipes if you want. On the right side there are the return values and the verification values, and on the left side are the input parameters. So I would always divide it somehow this way, but you don't have to actually. You just need a single pipe if you like. And now you can just provide our parameters here. We can say mic. When we want, if mic is in the list, so it should return true. If we have mark, as you might expect, it should return false. You could also try to test some edge cases like null, and it should return also false. Or we can check Peter. And if you have Peter in it, then it should return true. So if we run the test now, we could actually try that. Hopefully it passes. Hopefully I didn't do any mistakes. And we have just provided 4 different test cases in just a single method. That's pretty cool. But maybe you want something like, you want to, for each case you want a single method. So it would be odd to now split the methods. There's an annotation, it's called unroll, which just unrolls your data table. And to know which method you're actually in, you can somehow say provide or get access to the variables here. So you can say name, and this name here is the value of the data table. So if we execute the test again, we're actually not only having 1 test, we're having 4 tests. For each row, data set here, combination value, we get a single test case. And the method is named get animal. Oh, sorry, what did I do wrong? Oh, yes. Actually cannot rerun it, I have to run it again. Because the method name changed, so I couldn't rerun the test. So I have to restart the test execution here. So as I said, now there should be not only 1 test, there are 4 tests, yes. And you see how they are named, and the cool thing is if one of them fails, you can see why it failed, you know which input parameter caused the failure. That's pretty cool. There's also something very interesting. If you compare and did something wrong, we can just provide an error here, for example, and run the test. And see what Spock prints out for us. And Spock has really cool highlighting when it comes to comparing objects of your expectations. This is not very interesting for this case here, but if you have complex objects, Spock shows you what actually are the values for the different things here. So you see that found is an optional empty,